Hello, students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Community College, Torrance, California. So now we are back with design example 4, pizza cost calculation and order processing, video 3 of 5. And this part is dedicated to analysis. Now, analysis in this case, when if and else have been introduced, is one of the most important part of IOA. So I would recommend that you pay a lot of attention to this video, and of course you are going to have this document that I'm using for video production also available to you, so you can follow the document along with the video. Lab 102 analysis only included analyzing the mathematical formula used and converting math form of the formula to C++ form. Okay? But when we start to make decisions, like using selection if and else, another very important dimension creeps up, and that is that we execute certain algorithms only when either certain Boolean conditions are true or they are false. And that's a very important point to understand. Like, if some condition is true, what algorithm am I going to execute under the scope of that? And if there are only option are true and false, what will be executed under the false option? When you have two options, true options become if, false option becomes else. If you have many options, then you do if, else if, else, and there are situations where you would change those two. Okay, so I already mentioned in part 1 that cost of pizza will be computed in many parts. We'll fix the basic cost, then add, if order of the user says so, extra cost due to flour, and if they want exotic cheese, extra cost due to exotic cheeses, and if they want toppings, extra cost due to toppings. That's the math part of this software development. So let's see what that part is. So in this one, math and C++ form was almost identical. So we are only going to show C++ form. As I mentioned earlier, our total cost will be base cost, which is fixed by the table 1, increase due to flour, increase due to cheese, and increase due to topping. And here we're going to just give general formula for each case, like increase in flours will be base cost into the multiplier for the flour. So if it's 2% increase, this will be 2 divided by 100.0. Obviously, you can do some numbers in your head, but we wanted to make sure that all the details are presented here. Flour multipliers are on table 2, page 2, and we'll quickly go there and show you those. 2% for whole wheat, that's the multiplier. 4% for the organic whole wheat, 6% for the multigrain. And there are multipliers the same way for the other cases. Cheese increase will be base cost into cheese multiplier divided by 100.0, and that's on table 3, page 2. And we'll briefly, very briefly visit that. This table, 1% for extra cheese, 2% for jalapeno, 5% of the base cost. Each case base cost for the goat cheese. Okay, and then last one is topic increment. Almost all topping increments have added cost, could be 50 cents, could be anything. Then the multiplier, which gets multiplied with the base cost and divided by 100, and that's given on table 4, page 3. And we'll quickly go there, right here. So notice that if they want mushroom, we'll add 50 cents, and 1% is the multiplier to the base cost based on the pizza size, and so on. Okay, each case there is, don't want anything, there is no extra cost. Okay, so that pretty much explains our formula, this one, and what are these increments. Details of these increments are here, here, and here. What are these multipliers would be pretty much depending upon what they ordered, what code they entered, what number they entered for their choices. Once we get that, to get the whole dollars and whole cents of the cost, we have discussed this algorithm many times. First we get the total pennies, which is total cost into 100. We round them up after adding 0.5. This has been explained in a lot of depth in the class. This is really either to increase fractional penny. If it is 0.5 and above, it'll increase to whole cent. Otherwise, because of casting with int, it's going to just drop off. And then cost, dollar part of the cost will be rounded divided by 100. It truncates the remainder, and cents part would be rounded pennies, modulus with 100. That truncates the quotient, just gives you the pennies. So that's the math part. More importantly, now we go to Boolean conditions, Boolean flags, conditions, and software structure. This part is very important. It's very important that you understand that. That might require watching this video several times and perusing through this whole document, which will be available under the videos in our class. So it clarified in description that program execution may take many software paths. Each path will test cascade of Boolean conditions, and based on that, different computational algorithm will be executed, under each being true or false. We're going to show high-level logic here, partly using flowchart. Though logic is inferred by program description, chart makes it clear as how various paths are available for the flow of overall execution. So we have picture first. That's the picture. First 3 steps are user input. We're going to get the code that will give us the pizza size. We'll get the flour code. That'll be choice for the flour type. We'll get the cheese code. That'll be the choice for the cheese type. And finally, we get the topping code, which will tell us whether they want any topping or what kind of topping they want. It is very important to understand in this software, we get the user data, we do not process anything until all the user data is in. And that's not necessarily done in all software, but in this one we are doing it to understand how Boolean flags are set and how they are used. The student gets very confused by Boolean flags, but there is nothing to be confused about. I'm showing it to you right now. This is the Boolean variable that was there in our computational variable table. It says that there are many possibilities. User may have entered at this point uppercase S or uppercase M or core equals uppercase L or core equals uppercase X. Or operator means that if obviously they're going to enter one of these four, that if either this is true, either this is true, either this is true, either this is true, flag base call will get set to true. Only time this will get set to false will be that this is false, this is false, this is false, and this is false. In that case, we cannot process their order. This fact will be used very soon when we use the value of this flag. And we don't terminate the program here even if this is false. That's another requirement of this software or the lab 4 that you're writing. We don't terminate program until the end. We continue on the program. Of course, certain part of the program will not execute if any of the flag is false. Okay. Then we get the flower code, which could be 0, 1, 2, or 3. And that's an int type. We do not put quotes around that. So if flower code is 0 or flower code equals 1 or equals 2 or equals 3, if any of these conditions are true, this, and this, and only one can be true, of course, then because of the nature of the OR operator, remember from the truth table, in OR operator, if even one input is true, then output is true. And in that case, flag flower code will set to true. But if they didn't, let's say they enter -1 or 4 or 5, then this is false, this is false, this is false, this is false. So that also you know from the truth table, that if all inputs to an OR operator are false, then result is false. So if they didn't enter anything like 0, 1, 2, 3, then this will be set to false. But if they enter any of these, then we know what kind of pizza they want, and this will get set to true. Identical thing happens in the flag cheese code. If they enter uppercase R, E, J, or G as cheese code, which was gotten here, then we know what kind of pizza they want, what kind of cheese they want, and this flag will be set to true. But if this entry here is neither R, nor E, nor J, nor G, then this condition, this condition, this condition, and this condition, they're all false. In that case, this gets set to false. And finally, same thing is true about the topping code. We'll get that here. It could be 0, 1, 2, 3, 4, 5, or some other number, -1, 6, 8, anything. If it is not 0, 1, 2, 3, 4, or 5, then all these conditions, this, and this are false. One of these conditions has to be true in order for this flag to be true. If all these conditions, 1, 2, 3, 4, 5, 6 are false, then this will get set to false. So important thing to understand here is that if any of the flag is false, that means we did not get their choice for that particular component. And if we didn't get their choice, we cannot compute the cost. So further computation for cost calculation can only be done if all these four flags are true. 1, 2, 3, 4. So we use a if and else structure to do that. So as I said, after flag settings above, program will start to make decision based on the flag values, and there are only two possibilities. If all flags are true, then all user inputs can be processed to create their pizza. But if even one flag is false, that means we didn't get choice for one of the cases. Maybe we didn't get the choice for the correct pizza size, or correct type of flour, or invalid cheese code, or invalid topping code. Obviously, pizza has size, flour, cheese, and toppings. If either one of the input is missing, we cannot create the pizza. If we can't create the pizza, we cannot compute the cost. So if all the flags are true, then all user input can be processed to create their pizza. Otherwise, program cannot create pizza, in which case, based on errant output, we should show as to which input was in error, and whichever flag is false, that input is in error. So let's take an example. When we ask for the cheese type, if they didn't enter R, E, J, or G, and let's say they enter T, well, there's no T cheese code. Okay, so that input is an error, and we can tell them in the else block that your cheese input was wrong. So run the program again. And of course, all four could be wrong. So there's an interesting way to do that, how to output those error message in the else block. Okay, so let's take this case first, which is a long one. All flags are true. So this is how we are doing that here. And this is how the structure of overall software will look like in high-level algorithm or pseudocode. So here we are only showing tables of Boolean condition either under this case, and in this case we are just showing the selection structure that is used, and tables of Boolean condition that will be shown will be converted to algorithm in the video 4, which will be fourth video. Okay, so let's focus on this one. Okay, so we use structure like this: if flag base code and flag flour code and flag cheese code and flag topping code, then do this. Now you know from the truth table for AND operator, and hopefully you know that. If you don't know how truth table for AND operator, where we have shown only two inputs, but you could have more than two, it doesn't really matter. It shows that if Boolean values or expressions are joined by AND operator, if any of these is false, either this, or this, or all are false, then entire expression will evaluate to false. So only way I will enter under the scope of this if statement would be when all Boolean variables or Boolean values are true. And that we have mentioned before would be the case when all the user inputs have some valid values. Okay. Okay, I'm going to jump ahead a little bit and show you what happens if one of them is false, or two are false, or three are false, or all four are false. Then this Boolean expression will evaluate to false. None of these lines, 191, etc., will be done, and we'll be jumping directly to the else block, where we'll be checking each flag whether it was false or not. And don't forget, you cannot get here if all are true. One of them has to be false. Okay, you know that if Boolean expression for the if is true, then you never execute else. Okay, so else block is executed only if condition is false, and if condition, as you know, has those four flags. If either one of them is false, 2 are false, 3 are false, 4 are false, then all the code from 191, because we cannot compute the cost then, to 245 is skipped completely and goes to else block. Here we check which flag was false by negating it. Here's the use of the negation sign, which I had promised that we'll use at some point. So if flag base code was false, then negation will be true. And we said we print wrong size code was entered. But if this was true, the negation will be false, then this will not be printed. You spend some time on thinking about that, how this works. If they entered wrong value for the flower code, then this will be false, negation of that will be true, and program will print wrong flower code was entered. Same thing, if cheese code was false, negation will be true, and then program will print that. And if topping code was flag was false, negation will be true, and program will print that. Now, why are we using if structure here rather than if and else? Because you have no control over user as to how many errors they're making. If I use nested if and else here, if, else if, that means you're assuming user cannot make more than one error, but that's not true. How can you control user to make just one error? You cannot. This is a perfect case where nested if and else does not work. This is very important. Pay attention to this. This is the case where you have to do a standalone if, because user can make 4 errors, they can make 3 errors, they can make 1 error, they can make 2 errors. Anything is possible. Okay? This is the case where nested if and else will completely fail, because that would assume user would make only 1 error. No, that's not necessary. Okay? So we did the last part first. Now let's go back to computations, Boolean table conditions. When all 4 flags are true and they indeed give us valid value for all their choices, then all the 4 flags will be true. And then we'll see how the Boolean condition for each computation will proceed. One more thing I want to point out, your program for or IOA for lab 4 is not accepted unless this flag approach is used. There are many ways to do this program, but we are trying to teach you flag approach, which is a very, very important approach in command line environment where graphical user interface is not possible. And there are cases like server-side programming, you don't always have graphical user interface. And you have to use flags a lot of different places. So if lab 4 is not done by using flags, then your grade will be bare minimal in that. You may not actually even pass the lab 4. So that's why understanding this approach is very important. And we're spending a lot of time on that. Okay, so if all these 4 flags are true, that means I can compute the cost, base cost, cost due to flour, cost due to cheese, cost due to topping, and we're doing that one by one. So you can do them in any order, but we always have to compute the base cost first because all other costs like flour, cheese, and topping depend on that. They use a multiplier factor that gets multiplied to the base cost. So computing the base cost first is important. After that, you can do them in any order. But of course, I always do them in this order. Base cost, flour cost, cheese cost, and topping cost. Okay, so now this is how we do Boolean conditions table. We show the Boolean condition and its value, and we show what algorithm will be executed under that Boolean condition being true, and any realization we should have about that. Now, another important thing to realize is that when we do analysis of Boolean conditions, we are not telling user whether to use standalone if or nested if and else. Okay. But when we do algorithm, at that time we'll decide that, hey, using standalone ifs may be slow. So when only one of the four situation will be true, like you can only buy pizza of one size, then nested if and else will be faster. But in case of table of Boolean conditions, we don't worry about that. We just represent the condition, its value, and what algorithm is executed. There might be a situation when there might be a false task also, but we'll worry about that later. Okay. So if code entered equals s, if that is true, then our algorithm will set the base cost to $2. If code executed has the value m, and if that condition is true, then we set the base cost to 4. If code entered was L, then code equals L will be true, we set the base cost to 6. And if code entered was equals x, that's true, we set the base cost to 8. And obviously, in this order, these are costs of small, medium, large, and extra large pizza. And you remember from the math part of analysis that once base cost is determined, we can do the 3 increments. Increment due to flour, cheese, and topping. So now we're just going to do one of each, and you can read the rest in the document, and we'll highlight them in the video, of course. So let's manage increment due to flour, and the formula given was of this nature right here. There will be a base cost, there will be multiplier divided by 100, and I may not have 100 there, I can add that, not a problem. So if flour code equals 0 is true, then that means they want regular flour. Then increase into the flour is 0. That's regular flour. Okay. If they want whole wheat flour, then they have entered flour code 1. That means flour code equals 1 is true. And then increase in flour will be base cost. And I promise to you that I will use division by 100. So I'll change it to that form. Okay. So that'll be, because there were 2% of base cost, increase was 2% of base cost, so I multiply by 2, make it 0.0, divide by 100. And if they enter flour code 2, then flour code equals 2 will be true. Then they want organic whole wheat, and in that case, increase was 4%, so I'll make it 4.0 divided by 100.0. And if they enter flour code 3, then flour code equals 3 will be true. And then our flour increment will be base cost into multiplier, which was 6.0 divided by 100. That's multi-grain. And in the table, I've said 2%, 4%, 6%. 2% means this, 4% means this, 6% this. I've said 2% of base cost, 4% or 6%. Okay? Pause the video here, look at it, think about it, and become clear about that. Third is Boolean condition of the table to manage the increment due to type of cheese they ordered. So cheese code could have been R, E, J, or G. In each case, increment cost is different. If it's regular cheese, if they entered R, then this Boolean expression is true. And we have said in our condition that in that case we have no extra cost, so our cheese increment will be 0.0. That means they want just regular cheese, nothing exotic. But if they entered cheese score equals E, that means they want extra cheese, then this Boolean condition will be true. And if you go back to table 3 earlier, then it was 1% of the base cost. So once again, I'm just gonna do this, and of course that means the same thing. That means they want extra cheese. Okay, let me align this a bit. And if cheese score entered was J, then this Boolean condition is true. And then if you look at the cost table, we add 2% of the base cost. That'll become 2.0 divided by 100.0. That means they want jalapeno cheese. Okay, and this one and the other second line, that's fine. We can just make it a little smaller. Okay. And finally, if they enter cheese code G, that means they want goat cheese. In that case, this Boolean condition will be true. And our cheese increment will be 5% of the base cost. And as I promised to you that I'll just do it this way to eliminate any confusion. And once again, we'll see in the algorithm that these are all coded as nested if and else. There are some changes, of course. If we skip that, there will be some slightly different thing. Last one is compute the topping increment. That's table 4. Now, if then they could enter topping code 0, 1, 2, 3, 4, or 5. If they enter 0, that means this will be true, and our cost table early on says that we don't charge them anything. In that case, topping increment will be 0. But things are different for other toppings. We add the added cost in cents plus a % of the base cost. So if they want mushrooms, then they're going to enter 1, then this expression will be true, and topping increment will be 50 cents plus 1% of the base cost. And since we are doing it this way, okay, this gives you more chance to look at it while I'm fixing this. So keep looking at it. Okay, I'm just going to leave it in 2. And if they want shrimp, then they will enter topping code equal to 2. Then this Boolean condition will be true. And topping increment will be $1 plus, again, 1% of the base cost. That'll be this number here. Okay. I'm going to leave this misalignment because I don't have time to do it. If they enter topping code 3, then this Boolean condition will be true. And then topping increment will be $1 plus 15% of the base cost. And that will be this. If they enter topping code 4, then this condition will be true. That means they want peppers. And in that case, we add 50 cents plus 9% of the base cost. And what I've done, if they want all the toppings, then I just added these. 150, 150 will be $3. And if you enter all these, 9 plus 15, 10, 25. Okay, it should be 0.35. Let me go to my original table and see that. 10, 25. I'm getting it 36, so this 35 has got to be wrong. So let me go to the original table right here. So let's look here. 10, 10 is 25 plus 15 is 35. So it should be 35. So let's take a look at that. Yeah, 35 is correct. Yeah. So why am I getting 1% here? I think one of them has got to be wrong. 10, yeah, something's not right. Let me copy and paste that here, and then we'll see it. 110. Oh, okay, okay. Now I see it. One will be 110, 15. Let me just get this table there. You can delete it later. It's hard when things get confused, but we'll fix the confusion. Let me just paste it here actually. So 1% will be 1 divided by 100. Yes. Oh, this was 10%. Okay, that was my mistake. So this is actually 10. Yeah, now it's correct. 1, 10, 15, and 9. So this will be 10. 10 plus 15 is 25, 35. Now it's correct. Okay, good. So let's delete that. Yeah, these things happen. And last one, of course, will be 35.0 divided by 100.0. That's if they want all the toppings. So we just added these things. Okay. This we have reviewed before in the math formula. That's just reproduction of the same thing. Total cost will be base cost plus increase in flour, cheese increase, and topping increase. That could be any of these depending upon the if condition. And then this algorithm we have discussed before, and print dollars and cents. And else block executes, as I said before, that if one of the flags is false, that means one of the user input was wrong. So structure we are following here is that we compute the cost only if all user inputs are wrong. We don't exit the program. We don't tell them, okay, hey, you didn't input this right. We tell them at the end what they didn't input right. And obviously, line 247 and onwards, they will be skipped if even one of the Boolean flag is false. That means one of the input is wrong. So that's our analysis. In the algorithm part, we'll show you how this picture is done. That's pretty much the way you see here. We'll be setting flags. but details will be how we take these table of Boolean conditions and we set them to um, sorry use if and else, nested if and else rather than standalone if and else. How we convert these Boolean condition tables into selection structures, that would be the key part in the algorithm. All right, so this is Dr. Satish Singhal, PhD, saying goodbye from design example 4, pizza cost calculation order processing, video 3 or 5 on analysis. This is the most important video because our whole algorithm and then of course source code depends on this. Thank you and goodbye.